Good afternoon, everybody. We have seen in the last lecture that is biasing technique of the transistor. We just revise whatever thing we have studied in a last lecture, right? We have seen in the last lecture fixed biasing and the collector to base biasing. These are the two methods used for the purpose of biasing that we have seen here. Did you getting my voice? Please reply. Did you getting my voice?
Yes, sir.
Okay. In case of fixed biasing, what we have to do? See, above figure shows that the circuit diagram of fixed biasing configuration. See, in case of your fixed biasing, we have applying the fixed base voltage to the transistor through this resistor. This resistor indicate that RB resistor, right? So the value of this RB resistor does not changes. So whatever voltage provided through the VCC, that should not be changes. So it should be fixed. That's why it is called as fixed biasing configuration of the transistor, right? So this configuration also called as single base bias resistor method. This is also called as single base bias because whatever the voltage provided through the only base terminal. That's why it is also called as single base bias circuit also, this configuration, right? So how we have to be analyze this type of circuit? See, any of the circuit, biasing circuit, we have to be analyzing only by using mathematical equation of the particular condition. Normally, three things we have to be calculated by this circuit diagram, and according to we have to be analyze the particular configuration, right? So in this configuration, we have to be analyze three things, that is base current, collector current, and the collector to emitter voltage. These three things we have to be analyzed by this configuration. Here, see, this is the RB resistor. We decided the whatever the voltage provided to this base, that this is the collector resistance. Collector current which should be flowing through the RC resistors through the transistor, right? This voltage coming across this collector and emitter terminal, that is a VC, right? This is the voltage coming, and the voltage coming with respect to base to emitter terminal is a VBE, right? This voltage is coming with respect to VBE terminal. So for the analysis of the particular configuration, we have to be calculate the three things, which are that thing. So base current, then base current indicate that this is the input side. Collector current, this is indicated as a towards the output side. And another thing, collector to emitter voltage, it's also coming to the output side, but we have not calculating any IC. We have just used the formula, that is IC is equal to beta into IB. That is the formula only for the calculation of IC, but for the calculation of IB and for the calculation of VC, we have applied the KVL at input and output side respectively, right? For the calculation of IB, we have applied the input side. For the calculation of VC, we have applied the KVL at output side. So now we have to be calculate three things. This is nothing but analysis of the particular fixed biasing configuration. See, IB, IC, and VC, these things we have to be calculate. IB indicate that base current, right? So base current calculation, we have applying the KVL at input side. Input side indicate the startup with this plus VCC and turning towards this VB up to this VB. This is nothing but a input side. So when we have applying the KVL at input side, upper point plus point is taking as it is, right? So plus VCC, upper part is plus, lower part is minus. So plus VCC minus of IB into RB, minus of IB into RB, going towards the here plus point minus points. So plus VCC minus of IB into RB minus of VB. This is the equation coming with respect to input side. C, apply KVL to the input side. In that case, plus VCC minus of IB into RB and the minus of VB. This is the equation for the particular input side, right? We have need of the IB, right? So what we have to do? We have taking out the IB into RB one side, IB into RB another side. So minus taking another side it is as a plus. So plus IB RB, which is equal to VCC minus VB as it is. See, VCC minus VB as it is, minus IB into RB going another side, it is a plus IB into RB. So this is the equation, IB into RB, which is equal to VCC minus VB. So we know we have to be calculated the IB. So IB is taking one side, RB going another side, right? So IB equal to, this is multiply, take going another side as a divided. So IB equal to VCC minus VB divided by RB. This is the equation for the IB, right? So when we have to be calculate the particular things such as IC, so we know that the equation of IC is equal to beta time IB. What it indicates that there should be relationship between collector current and the beta and the base current, right? So it is the relation is nothing but IC is equal to beta times IB, right? So that what we have to do, see, when we have to be calculate the IC, in that case IC equal to beta times IB. So IC equal to beta and IB multiply by this IB. This IB indicate that here particular value of IB VCC minus VB divided by RB. So beta times VCC minus VB divided by RB. This is the calculation for the purpose of your IC, right? So when we have to be calculating the VC, see, VC term came with respect to output. So to calculate the VC, we have to be apply the KVL at output side, right? Output side starting with this plus VCC and ending with this ground, right? So plus VCC, so plus VCC minus of IC into RC minus of VC. These three things coming with respect to the when we are applying the KVL at output side. C plus VCC minus of IC into RC minus of VC. See here. Apply KVL to the output side. In that case, VCC minus of IC into RC minus of VC. This is the equation, right? We have to be calculate the VC, right? For that purpose, what we have to do, taking minus VC another side as a plus VC. Okay. So plus VC equal to VCC minus IC into RC. VCC minus IC into RC. So in this equation means for the analysis of the fixed biasing configuration, we are applying the KVL at input side and KVL at output side. We have to be applying KVL at input side. We have to be calculate the IB and IC. Why IC? Because we know that IC is nothing but a beta times IB. Then when we are applying the KVL at output side, in that case, we have to be calculate the VC. These are the things with respect to the this fixed biasing configuration. Some of the advantages and disadvantages of this thing is that, see, for that configuration, there should not be stability. Stability indicate that there are so many factors coming with respect to the stability of this type of configuration. See, this is the configuration which have beta factor pattern. So beta indicate that it is related to the transistor. We know that transistor is a semiconductor devices. As temperature increases, all of the thing of the transistor that should be changing, right? So it changing indicate that whatever the operating point, what are the operating point of this particular transistor, that should be changes. So what happened due to the changing in the operating point, all of the things means operations with respect to transistor changes. So this type of configuration doesn't have the means this type of configuration have the changing in the beta is possible. So that's why another thing for that this type of configuration is that all the time there should be changes of the beta and all other parameter with respect to this type of configuration. So this is not method used for all of the application for the biasing a transistor. Some of the, see, one of the bigger advantages of this type of configuration, it have also some of the disadvantages, but we have to be consider the some of the advantages of it. See, this configuration required less number of components. That is biggest advantages. And another disadvantages is that, sorry, another advantages is that when we have to be fix the particular RB registers indicate that, see, this register, only one register is required to providing the base supply to the transistor. Okay, this is the advantages. And this design, only some of the component requirements, flexibility is more in this type of configuration. There are so many disadvantages coming with respect to this type of configuration. We know that beta, we know that collector current is nothing but a beta times IB. So beta should be related with the semiconductor. It should be changes from device to device, right? So that's why beta changes due to the temperature. So there should not be control of the temperature changing, right, with respect to our nature. So this is the disadvantages of this type of configuration. Another thing, poor thermal stability. What it indicates that, see, we know that IC equal to beta times IB. So beta should be changes as temperature should be changes, right? Or environmental thing also changes. So it have less thermal stability. Thermal stability will indicate that temperature effect, right? Then so here beta is depend on collector current. Another thing, you know that if we have to be transistor of BC547 of the one of the manufacturer, right, it have beta of 100. If other manufacturer, right, it have the transistor of the BC547 same, it have beta of 110, right? So beta of the particular same type of configuration are changes, means as manufacturer changes or the person changes, beta should be changes. There should not be same beta for the particular type of transistor, right? So that causes effect on your operating point of your transistor, right? And another thing, the fixed bias configuration stability, because beta changes, all the thing changes. So stability of this type of configuration is poor, very poor, right? This thing should be related to the fixed bias circuit. Did you understand the concept? लक्षात आलंय का फिक्स्ड बायस कॉन्फिगरेशन? आपण आधी घेतलेलं आहे खरं तर, हे फक्त रिवाइज म्हणून थोडं जरा फास्ट घेतलंय मी. आलं लक्षात आलंय?
Yes, sir.
Okay. Now we have seen the another type of चालेल ना मधून असं म्हणजे थोडस फक्त जे पार्ट झालेलं असेल ना, तुम्ही थोडस फक्त एक दोन ओळीत किंवा मराठी कमीत कमी यूज करत जाईल, जेणेकरून तुम्हाला आधी झालेलं असेल. चालेल ना? का थोडंफार जास्त मराठी पाहिजे तुम्हाला सांगा तुमच्यानुसार, म्हणजे लास्टला तरी प्लीज रिप्लाय द्या. म्हणजे पहिल्यांदा आधी शिकवलेलं असेल ना ते मी टोटली इंग्लिश मध्ये परत बोलू जाईल, आणि जर काय प्रॉब्लेम असेल कोणी विचारलं तर थोडस मराठीत सांगितलं जाईल. चालेल ना?
Okay, sir.
Okay.
Yes, sir.
Okay. Now we have seen one of the important topic of this session, that is collector to base biasing method. This method is also called as collector feedback method, right? Why it is called as collector feedback method? See, this is the configuration. In this configuration, we have to use the feedback of collector to the base, right? See here, this is the collector terminal. The feedback of collector is taking and it is applied to the base. That's why it is called as collector feedback method. Another name for the collector to base biasing method, right? So same configuration, we have to be calculate three things, same as like as earlier configuration. One is your IB, other is your IC, and third is VC. See, when in a exam question asked on the same point, the question asked same way, I'm telling you, derive the equation of collector to base biasing method and explain, right? In that case, you have to be write down only the things, means mathematical analysis only, no need of the theory part of this type of question, right? In case of theory exam, but in MCQ they have to be asked any of the middle step of the particular configuration. Okay, now see, this is the collector to base biasing method. Now in this configuration we have to be calculate three things, IB, IC, and VC. So we know that IB indicate that base current, IC indicate that collector current, VC indicate that collector to emitter voltage. We know that IB is related to the input side, IC is related to the beta times IB, means it also related to the input side, and the VC it is related to the output side. So when we have to be calculate the IB indicate that base current. In that case, we have to be apply the KVL at input side, right? So during this input side, when we are applying the KVL, in that case, see, current flowing through this type of, means through the collector is not only the collector current. Why it is? Because there should be feedback of your collector to the base, so that current through this collector is not only collector current, it should be addition with the base current, right? So current flowing through this type is IC plus IB. This is due to the only feedback from your collector to the base. That is the reason behind it is. So when we have to be calculating the base current, in that case we are applying the KVL at input side, right? This is the input side. Start up with this thing, right? This and traveling to this and going towards the here, right? So it is a plus VCC, right here plus minus, so here minus term. plus VCC minus of IC plus IB into RC. Why minus? Because second point is minus. So minus of IC plus IB into RC. Then it should be traveling towards the here to the RB. So it is a minus IB into RB. This should be going towards the here. Whatever the voltage coming across here, VB. So it is a minus VB. So total is plus VCC minus of IC plus IB into RC minus of IB into RB minus of VB. This is the thing with respect to your equation. See, plus VCC minus of IC plus IB into RC minus of IB into RB minus of VB. We have to be calculate the thing with respect to IB. So that what we have to do, we have minus IB into RB going another side. So it is nothing but a C equation, VCC minus of VB. We have separate out VCC minus of VB separate out. And another thing, IC plus IB into RC plus IB into RB, because from this side to the another side. Okay. So VCC minus VB, which is equal to IB into C, IC multiply by RC, IB multiply RC. It is nothing but IC into RC, IB into RC. C. So VCC minus VB, which is equal to IB into RC plus IC into RC and IB into RB as it is, right? So we know that we have calculated the things related to this configuration. Initially, this is the equation we have to be, we know that IC is equal to beta times IB, right? IC is equal to beta times IB. So what it indicates that where the IC is coming, we have to write it as a beta times IB. So VCC minus VB, which is equal to IB into RC, IC. For that purpose, we have to be write the beta times IB, right, into RC. Here IB into RB as it is. Okay. So VCC minus VB. Now see IB, this should be coming in each equation, so that we have to be common it. So IB into bracket of RC plus beta RC plus RB, right? This is the equation coming with respect to the IB. Now VCC minus VB, IB of RC. Now see, during this equation, what we have to do? See, VCC minus VB as it is, IB. So RC as it is, but here RC taking as a common. So RC here 1 plus beta, RC into 1 plus beta plus RB. This should be coming, right? So after all that, VCC minus VB, which is equal to IB, Now we have taken RB as first. So RB plus now 1 plus beta into RC, here and there only changing, right? RB plus 1 plus beta into RC. Okay. So why we have to do the same thing? Because we have to be calculated the base currents, right? So base current taking here and this multiply thing going outside as a divided, right? So base current equal to VCC minus VB divided by RB plus 1 plus beta RC. See, VCC minus VB divided by RB plus 1 plus beta into RC. This is the whatever the base current coming with respect to us. Now see, we know that when we have to be calculate the IC, we know that IC is nothing but a beta times IB. So IC equal to beta times whatever the Euler equation, that is VCC minus VB divided by RB plus 1 plus beta into RC, right? This is the thing for the calculation of IC. Now we have to be calculate the VC. We know that VC part is towards the outside, that is outward, right? This output section, right? So that we have to be apply the KVL at output side, right? So VCC minus of IC plus IB into RC minus of VC. This is the equation for the output side. See, again I'm telling you, when we are applying the KVL at output side this is, so plus VCC minus of IC plus IB into RC minus of VC. See, VCC minus of IC plus IB into RC minus of VC. Okay, this is the equation. We have to be calculate the VC. That's why this minus going here as a plus. So VC equal to phi c equal to PCC minus of IC plus IB into RC. This is the equation coming with respect to VC. Okay, did you understand this thing? लक्षात आलंय का? Collector to base biasing method लक्षात आली का? Reply द्या.
Yes, sir.
Okay. Now we have seen, as we have completed the revised part. Now we have seen the topic, that is voltage divider biasing meeting. See, all of the application here we have to be used the transistor. This is the mostly used method for the biasing of your transistor. The reason behind it is that it gives the more positive output, as well as it doesn't requirement of the any disadvantages also. This type of any disadvantage across this type of configuration. This is the reason why the voltage divider biasing used more. See, this is the configuration R1, R2, RC, and RE. These are the four resistors used for that type of configuration. We are applying the plus VCC as the voltage source for the particular resistance, right? This resistance act as a voltage divider network. Means whatever the voltage coming from this VCC, that should be divided by these two resistors, that is R1 and R2, right? So see, due to that this two R1 and R2 analysis, mathematical analysis, not easy, right? Because voltage is coming across R1 is as a V1, voltage coming as R2 as a V2. If we have to be analyze the same thing by doing this way, we have to be more, we have requirement of large time and complexity is more, right? So that's why what we have to do, we have to be replaced by this R1 and R2 by applying the Thevenin's theorem across it, right? So in that case, we have to be considered as the voltage coming from this is considered as a VTH, right? VTH, and the resistance of that particular two resistors, it should be considered as a RTH, right? Means VTH is the voltage coming across these two resistors, and RTH is the equivalent resistance of these two resistors, right? Means to analyzing this, we have to be done the same thing, right? Now see, this should be shortened as here. See, these two resistors considered as the these two resistors considered as RTH. Whatever the voltage generated by this two R1 and R2, this should be considered as a VTH voltage. Okay, now this should be applied to the transistor, right? This should be applied to the transistor. All other things are same. This is the simplified circuit of the voltage divider biasing. This is for the purpose of analysis of particular configuration, right? If the analysis is done by using this type of configuration, complexity is more, right? This type of configuration, so that we have to be analyzed by this method. See, we know that, see, we are applying the Thevenin's theorem across it. It indicates that here we have applied the Thevenin's theorem. So when we have to be see equivalent circuit of this R1 and R2, in that case, what we have to do? See, when we have to be applying the Thevenin's theorem across this terminal, in that case, this resistance means R2, this resistance divided by both resistors into applied voltage. This is the equivalent thing of the particular Thevenin's theorem. So it is nothing but a R2 divided by R1 plus R2 into plus VCC. That is the equivalent particular thing with respect to VTH. So VTH is nothing but a R2 divided by R1 plus R2 into plus VCC. Here, R2 divided by R1 plus R2 into plus VCC. That is the VTH. It is indicate that Thevenin's voltage, right? So in this case also we have to be calculate three things, that is a base current, collector current, and VC. So to calculate the base current, we have applying the KVL at input side. See, apply KVL at the input side. So input side indicate that this is the side, right? This, and this way, right? So start up with this point. It is taken as it is. So VTH minus of IB into RTH minus of VB minus of VB minus of C minus of I into RE. So total equation for that is VTH minus of IB into RTH minus of VB minus of I into RE. See this equation. See VTH minus of IB into RTH minus of VB minus of I into RE. See I into RE. This is the equation coming with respect to us, right? Now what we have to do, this VTH, this VTH taking minus VB as a same side, means this should be taking as same side, all other thing going on another side. So VTH minus VB, which is equal to IB into RTH I into RE, because this minus going on other side as a plus. So VTH minus VB, which is equal to IB into RTH plus I into RE. This is the thing with respect to your equation number 1. What we have to do in this equation, we have to be separate out the VTH and VB on one side, VTH and VB one side, and this minus IB into RTH and minus I into RE on another side. So it is nothing but a VTH minus VB, which is equal to IB into RTH minus going another side as a positive IB into RTH and plus I into RE. Okay, now we know that one of the equation with respect to emitter current, right? Transistor, one of the equation, as we have seen the equation in a last configuration, means in the mathematical analysis we have seen this equation, right? I equal to IC plus IB, right? So here our I is come, in that case we have to use the IC plus IB. So here we know that I equal to IC plus IB. This is the equation. Another thing we know that IC is nothing but a beta times IB. So I equal to IC is nothing but a beta times IB plus IB. This is the equation for the I, right? So when we have to see in that I equal to, we have taking IB as a common. So IB into beta plus 1, right? So I equal to beta plus 1 into IB. This is the equation coming with respect to us, right? We have to be put out the same equation in a equation number 1. This is the equation number 1, right? So wherever the IE come, we have to put out 1 plus beta into IB. So in this equation, see VTH minus VB as it is, right? IB into RTH as it is. IE is coming, in that case we have to use the beta into IB, right? Beta plus 1 into IB, beta plus 1 into IB, and the another thing RA as it is, RA as it is. See what we have to do in this equation. See, this is the equation number 1, right? We know that equation number 1, we have to be to the value of the IE, we have to be calculated the value of IE value is 1 plus beta into IB. So we have to put out this value, this I value, on this equation, right? So that VTH minus VB as it is, right? So IB into RTH as it is, and I, for the I we have to be put out as a 1 plus beta into IB, right? 1 plus beta into IB, right? And RE is as it is, RE as it is. Okay, now VTH minus VB. Now see, we are taking IB common, because here is IB, here also IB. So IB RTH plus 1 plus beta, because here IB taken 1 plus beta into RE, 1 plus beta into RE. Okay, so to calculate the IB, we are taking IB as it is here. So IB equal to VTH minus VB divided by RTH plus 1 plus beta into RE. See, VTH minus VB divided by RTH plus 1 plus beta into RE. This is the equation for the calculation of base current. Now see, we know that when we have to be calculate the IC, we have to follow the things such as IC is equal to beta times IB, right? So beta indicate that same beta, and IB indicate that this beta into VTH minus VB divided by RTH plus 1 plus beta into RE. See here, beta into this equation, right? This is the equation when we have to be calculating the IC. IC is equal to beta times IB. We have to be beta as it is, taking IB equation here, right? This is the thing with respect to the calculation of IC. So see, during this equation, to calculate now VC, we have to be calculate the IB and IC. Now we have to be calculate the VC. So what we have to do to calculate the VC? Tell me. So we have applying the KVL at output side, right? So plus VCC minus of IC into RC minus of VC minus of I into RE. I'm again tell you, when we have applied calculating the VC, in that case we are applying the KVL at output side. So plus VCC minus of IC into RC minus of VC minus of I into RE. See here. So in that case, plus VCC minus of IC into RC minus of VC minus of I into RE. So we know that one of the relationship I equal to IC, right? Means wherever I is coming, in that case we have to be put out IC. So plus VCC minus of IC into RC minus of VC I we put out as IC. So IC into RE, which is equal to 0. So VCC minus of taking IC common, right? In this equation, VCC minus of IC into bracket of RC plus RE, RC plus RE. This minus VC going on other side as a plus VC. So VCC minus IC into bracket of RC plus RE, which is equal to VC. This is the equation for the calculation of VC. Did you get it? This value? लक्षात आलंय का हे? Please reply that. कुठे डिवाइडर बायसिंग लक्षात आलंय का? परत सांगावं लागेल का? सरळ सांगायचं, जर नसेल लक्षात आलं तर काही प्रॉब्लेम नाही. प्लीज रिप्लाय द्या. ऐश्वर्या गायकवाड, लक्षात आलंय का? परत सांगू थोडक्यात अजून?
यस सर, आले.
आलंय, ओके. सुशांत कदम लक्षात आलंय का? सुशांत कदम.
Yes, sir.
ओके. See, we have seen one of the important thing as a leakage current. What do you mean by leakage current? See, when we have to be operating the transistor, in that case, some of the leakage current means the current which should be leakage by this type of configuration, that is called as leakage current, right? We have discussing whatever the value of the leakage current and what do you mean by the particular leakage current through the mathematical analysis. See, we have calculating this leakage current through the mathematically. We have to be analyze what is the leakage current and whatever the value of the particular leakage current, right? For that purpose, we know that we have to be a relation, that is emitter current relation, right? So we know that emitter current is nothing but IC plus IB. But see, आत्ताच आपण सांगितलं होतं पहा की I इक्वल टू IC प्लस IB आहे, बरोबर. पण मी तुम्हाला ह्याच्या आधी पण एकदा म्हटलं होतं I इक्वल टू IC असतं. कसं काय? टेल मी हाऊ इट इज. I इक्वल टू IC प्लस IB आता आपण पाहतोय. पण मी मगाच्या इक्वेशन मध्ये I जिथं आलं तिथं IC आपण कन्सिडर केलं. नेल इक्वल टू IC का बरं असं? The reason behind it is the value of IB indicates that base current is very less, that is negligible value. That's why I equal to IC or I equal to IC plus IB, and this is the equation, right? So we know that one of the mathematical हे तुम्हाला पूर्ण आहे हे जे equation जे fair IC equal to alpha DC into IB, sorry alpha DC into IE plus ICBO हे एक equation आहे. See, when we have to be calculating the I equal to IC plus IB, in that case we know that means this is already designed equation IC equal to alpha DC into IE plus ICBO. This is the equation we know that with respect to the collector current, right? So for that purposes we have to be rearrange the equation, right? So we know that wherever IC is coming, right? Wherever IC is coming, in that case, we have to use the alpha DC into IE plus ICBO. 1 minute. ओके, रिपीट करायचंय का? ओके ओके. मला थोडं हे ना सांगा जावा ना. ओके, मेसेज मी आता पाहिला, रिपीट करतो, काय प्रॉब्लेम नाही. मेसेज आता मी पाहिला, रिपीट करतोय. ओके. See, we have seen again voltage divider biasing method. What do you mean by this? Is the mostly used biasing method for the purpose of your transistor, right? Why that is mostly used? Because whatever the output coming across it causes, it doesn't have any disadvantages, right? That's why it is more used method of the biasing of your transistor, right? So what we have to do? See, we have to be use here two resistors. See, R1 and R2 resistor. These two resistors are called as biasing resistor, right? Again, we have applying the plus VCC as the power for the particular all of the network. Then one of the resistors which should be connected across your collector, that is called as RC resistors. Then output, then emitter also have one of the resistors is connected, that is called as emitter resistors, right? This is the base terminal. Now see, this is the voltage divider biasing method. As the same method means same circuit is used for the purpose of your voltage divider biasing, but see, when we have to be analyze this type of configuration, there should be complexities more. So that's why here what we have to do, the R1, the voltage coming across R1, that should be considered as a V1 voltage. Voltage coming across R2, that should be considered as a V2 voltage. The analysis of both things is not easy, right? That's why we have applied the Thevenin theorem to this type of configuration, right here, and we have to be reduce this circuit as seen here, which causes analysis is simple, right? So that this R1 and R2, for that purpose we have applying the Thevenin's theorem, right? When we have applying the Thevenin's theorem, in that case applying Thevenin theorem across this point, so this is nothing but a resistance R2. So VTH equal to means VTH value, this value is nothing but a secondary resistance, that is R2 divided by R1 plus R2 into applied voltage, that is plus VCC. So VTH equal to R2 divided by R1 plus R2 into VCC. This is the value of the VTH. See, R2 divided by R1 plus R2 into VCC. So this is the VTH. Now whatever the current flowing through this base, this should be considered as a base current, and means two things are here important. Whatever the voltage flowing through this V1 and V2, this voltage should be, when we are applying the QL, then it should be considered as a Thevenin voltage, equivalent voltage. Now see, these two resistors, it should be considered as a RTH, means equivalent to two resistors of the R1 and R2, that is a RTH, right? All other circuit are same, right? So for the purpose of analysis, we have same thing calculate here, IB, IC and the VC, right? So calculating the IB, we have applying the KVL at input side. To calculating the IC, we have to use the equation, that is IC is equal to beta times IB, and to calculate the next thing, that is VC, we have applied the KVL at output side, right? So see, we know that VTH equal to R2 divided by R1 plus R2 into VCC. Now calculation of IB. So to calculate the IB, we have applied the KVL at input side. Let's start up with this part as it is. So VTH minus of IB into RTH minus of VB. Now see, start up with this and end up with again this, right? So that this point also coming. So VTH minus of IB into RTH minus of VB minus of I into RE. This is nothing but a equation, right? See the equation. Apply KVL at input side, VTH minus IB into RTH minus of VB minus of I into RE, right? I into RE. This is the equation. right? So that in that equation we have separate out this VTH and this VB, separate out VTH minus VB, right? VTH minus VB and IB into RTH, and the I into RE going on another side, it is a negative going as a positive. So IB into RTH plus I into RE. So we know that I equal to IC plus IB. So same thing. So same thing we have to use here, right? So I equal to IC plus IB, but we know that IC is nothing but a beta times IB. So IE equal to beta times IB plus IB as it is, right? So in that equation we have taking as IB common. So IB common, 1 plus beta remaining, 1 plus beta. Okay. So IE equal to 1 plus beta into IB. Okay. Now VTH minus VB as it is, which is equal to this equation. Now see, VTH minus VB as it is in that side, in that equation, we have to be, see, in that equation we indicate that equation number 1. In that equation, we have to be put out the value of the whatever calculated for the I, right? So for that purposes, VTH minus VB as it is, VTH minus VB, IB into RTH as it is. For the purpose of I, we have to put out the for the purpose of I, we have to be put out the beta plus 1 into IB. So here beta plus 1 into IB, beta plus 1 into IB, RE as it is, RE as it is. Okay. Now see, VTH minus VB, which is equal to IB taking as a common, because here is IB, here also IB. So IB into RTH plus 1 plus beta into RE. This is the equation coming with respect to us. Why we have to do? Because separate out the IB. So IB taking as here, and this should be going as multiplied as a divided. So VTH minus VB divided by RTH plus 1 plus beta into RE. This is the equation with respect to IB. Means here we have to be calculate the IB value. That is IB indicate that this current value. See, now we have to be calculate the IC. We know that equation for the calculation of IC, that is a beta times IB. So IC is equal to beta times IB. We have to be calculate the IB. So IB indicate that this VTH minus VB divided by RTH plus 1 plus beta into RE. So we have to be taking here into beta times. So IC is equal to beta times this value. Okay, this should be related to the calculation of the IB and IC. Now to calculate the VC, we have applying the KVL at output side, right? So plus VCC minus of IC into RC minus of VC minus of I into RE. This is the further calculation of your VC, right? So the equation for it is plus VCC minus of IC into RC minus of VC minus of I into RE. See here. Applying KVL to the output side, plus VCC minus of IC into RC minus of VC minus of I into RE. This is the equation. We have seen that I nearly equal to IC. Why? Because IB value is very less. So that wherever I is coming, we have to put out as a IC. So plus VCC minus of IC into RC minus of VC minus of I. For that purpose, we have used IC. So IC into RE, which is equal to 0. Now VCC minus of taking IC common, right? So VCC minus of IC common as a RC and RE. So IC into bracket of RC plus RE, right, which is equal to VC, right? So VC equal to VCC minus of IC into bracket of RC plus RE. This is the thing as we have to be calculating with respect to VC. आता लक्षात आलं का? Please reply द्या.
Yes, sir.
Okay. जर लक्षात आलं नाही तर म्हणजे असं मेसेज करत जावा किंवा सांगत जावा. Concept of leakage current. What do you mean by leakage current? That we have discussed first, and then we have to be going on the next slide. So see, leakage current indicate that when we have applying the voltage or current to the transistor, then all of the current or voltage applied across it is not as a output. Some of the current act as a leakage current, means it going on leakage, right? This is nothing but a leakage current, right? So for that leakage current, there is a one of the equation or the relationship between the equation, that is emitter current equal to collector current plus base current. We know that we normally consider as I equal to IC. Why it is? Because whatever the value of the base current, that should be negligible, right? Negligible. That's why I equal to IC plus IB we have taken. Another, see, for the calculation of this thing, we have to be required one of the equation, that is a IC equation. Means this equation is already designed for the purpose of our calculation. We have to be use it. So IC equal to alpha DC into IE plus 1 plus ICBO. This is the one of the equation for the IC, right? So what this equation shows, see, this equation should tell the value of IC with respect to relationship of alpha, right? तर लक्षात घ्या, ज्यावेळेस आपण I equal to IC plus IB पाहत होतो ना, इक्वेशन ज्यावेळेस पाहतोय ना, तर यामध्ये एक IC टर्म आलेली आहे, इक्वल टू IC प्लस IB, बरोबर. तर IC म्हणजेच काय असते आपल्याला माहिती असावं. याच्यासाठी आपण काय करतोय, एक इक्वेशन होतं त्या आधी डिझाईन होतं, IC इक्वल टू अल्फा DC इंटू IE प्लस ICBO, राईट. त्याच्यासाठी आपण काय करतोय, आता ही इक्वेशन रिअरेंज करतोय, लक्षात घ्या याच्यासाठी. तर यामध्ये पहा, IE जे आहे ना, त्याच्यासाठी आपण काहीतरी रिअरेंजमेंट करतोय. पहा, रिअरेंजिंग दिस इक्वेशन टू गेट IC minus ICBO, right? IC minus ICBO, which is equal to alpha DC into IE, right? This is the equation for IC. तेच इक्वेशन IC चं पहा, म्हणजे अल्फा DC याच्यातनं काय करायचं, अल्फा DC ची व्हॅल्यू आपल्याला फाइंड आउट करायची. सो टू फाइंड आउट द अल्फा DC व्हॅल्यू, we know that IC is equal to alpha DC into IE plus ICBO. So we have taken alpha DC on one side, that is alpha DC into IE one side, and this plus ICBO going on another side. It is nothing but a IC plus is going on another side as a minus, IC minus of ICBO, okay, which is equal to alpha DC into IE, right? So for that purposes, this alpha DC, see, this alpha DC into IE, this alpha DC multiplied by IE, so going on another side, it should be going as a divided. So it is nothing but IC divided by alpha DC minus of I common. Either you have to write as a IC minus ICBO divided by alpha DC, or separate out IC divided by alpha DC minus of ICBO divided by alpha DC, right? Which is equal to IE, because alpha DC going here. So IE, so we know that again I equal to IC plus IB. So equation for the particular case is IC divided by alpha DC minus of ICBO divided by alpha DC, which is equal to IE, which is equal to IE is nothing but IC plus IB. This is the equation coming, right? So during this equation, we have taking out the IC common, right? Taking out IC common. So IC is coming with this respect to this equation, right? So IC is going outside. So here 1 is coming, right? 1 divided by alpha DC. So see here the term, related to this configuration, ICBO and alpha DC, it should be taking as a 1, right? So equation coming is 1 divided by alpha DC, and this is act as a 1. Why it is 1? See the relationship of
Khadke sir. Hello. Sorry for the interruption. Actually, one very important session related to the Infosys registration is going on. So please end the session here only. So all the students listen carefully. I have posted one link in the SYB group. Immediately you join on that group. Okay, even 2 to 3 classes cancelled. You have to attend that session. Today is the last date for the Infosys registration. For that reason, we have arranged a session. So you attend that one immediately.
Okay, sir. Can I say?
Sir, we end the meeting first.
Okay. So we have seen the concept of leakage current in our next lecture. Now we have to be stopped.
So sir, you can explain in the next day. Immediately we end it here only.
Okay.
You can take another class and you can explain.
Okay, and we have to be stopped here.